Hello everyone. Today we are going to solve the problem longest common prefix of strings. So it is a difficulty easy question. So given an array of strings ARR, we need to return the largest common prefix among each and every strings present in the array. So if there is no prefix common in all the strings, we need to return the empty string. So the given array is ARR. Coming to the first example, GeeksforGeeks, Geeks, Geek, Geezer. So if you observe from all the given 4 strings, the GEE is common between every single word. So the output is GEE. But in the second example, hello and world, the prefix, not even the first character, is equal. So it is an empty string. So this is a time and space complexities expected one. So our approach is going to be, we will see now. So now the input given, the first example is GeeksforGeeks, Geeks, Geek, Geezer. So our logic will be step 1. The first string from the given array we will assume as a prefix. So initially the prefix we will assume as GeeksforGeeks. This is what we are going to assume as a prefix at the starting or the beginning. So we will do that. So the second step is going to be, we assume the prefix is a GeeksforGeeks at the initially state. So we keep on check from the 1 to n minus strings, which will be if the prefix index is at 0 or not. So if the prefix index in the each string is at 0, then it is a prefix obviously. So now we will check in this example. So in the given example we can see so the prefix GeeksforGeeks is there. Now if you see the second one, the string is geeks. So if GeeksforGeeks index in the geeks is at 0 or not, so we can see the prefix length is only greater than the geeks. So what do we do if we don't find the index is at 0? So if index not is at 0, then simply remove one character from last of prefix. So we will just remove one character from the last of the prefix. So we will do this continuously. So if anywhere between, if prefix becomes empty, then return it. So if anywhere the prefix becomes empty, then obviously we already got our output, which is the empty string. Then immediately return the empty string only without any further execution. So now we will observe the given example. So in the GeeksforGeeks, the geeks, we can see the prefix is not, so simply the GeeksforGeeks. GeeksforGeeks. So now we will dry run with one sample example. So GeeksforGeeks is now at the another step. So we will again check with geeks, which is a index 1 string. So we can also say again it is not equal to. So we keep on removing one by one character up to here. After that we will check geeks and geeks, they both are matching. Then iteration 1 is I is equals to 1 is checked. Then again the prefix is now at which is geeks. So again we check with the third string. What is the third string? It is geek. So until the end of the array we will check with each string. So again geeks is not matching the prefix index. So we remove one character from the prefix. So after that we can see it is matching. Now the string became geek only, the prefix one. So I is equals to 2 is completed. Now the third string at I is equals to 3 is, we can see geek. So it's directly matching. So I is equals to 3 is also completed like this. But now the prefix is geek and the last string, which is I is equals to 4 index, is geezer. So now we check its index in this given string. If the index I is equals to 4, then we can see it is not matching. The index of geek is not anywhere in this string, so we remove one character. Now the prefix became GEE, but now if you see, it occurs in the index I is equals to 0 in the string, the whole string. So it is present. So the whole iteration is completed. What was the last prefix value at the last of execution? It is GE. So output is GEE. So this is how we are going to do. So this is a first example. The prefix we are going to initialize as a first string. So we will compare with each string from I is equals to 1 to n minus 1. The string which, if the prefix index is at 0 or not in each string. So if the prefix is not occurring at the index 0, then simply remove the character from the last of the prefix. So if prefix becomes empty anywhere between, then we need to return it. So this is one example. So this is our logic. So we initialize the prefix, we iterate through the array, we check if the index of the prefix is at the 0th index of the each string or not. If it is not, then remove one character, the last one, from the prefix string. So if anywhere between the process the prefix become empty, then return it simply. So this is the logics. So now we will use the same logic in the code also. So we will write some base cases. So before processing, why not can we check if the given array is already null, or we can see the constraints. The array length is always greater than 1, so at least one string. So there is no need of writing the base cases. Now we said first we will initialize a string which is a prefix is equals to the first string from the array, which is array of 0, first string. So now we compare it with a string from I is equals to 1 to I less than length. So let us declare a variable length simply int n is equals to length. So we compare from I is equals to 1 string to the n minus 1, so I plus plus. So while our current string, which is array of 5 dot index of, which index we need to check? The prefix index. If the prefix index is not equal to 0, which we wrote in the logic, then simply we need to remove one character from the last. So prefix is equals to prefix dot substring of 0 to prefix dot length minus 1. So like that. So this substring gives us a string which removes the last character. So we also wrote that if anywhere between the prefix dot length is equals to 0, then simply return the empty string. If all the process is successful, then return the prefix value. So you can see our output is geek. We need to check until end because less than, okay. Now we wrote in our actual logic, which is we will initialize a string prefix which is the first value from the array. We check the string, the prefix one, with each string which is from I equals to 1 to n, the n minus 1 string also. So while in the process, until our prefix is not at the 0th index of any string, we will continuously remove the last character from the prefix. And if anywhere between the prefix becomes length equal to 0, then it is a output is empty string. So if actually there is a prefix exists, like in the first example the GE, then simply return the prefix value 1. So if we submit the hidden test cases, so you can see the program passed all the test cases. So this is a small code. So we only discuss the code for any program which is the most optimized one. So this particular program is the best way to solve this program, the most efficient way, and also easy to understand. So now we will analyze the time and space complexities. So we know a simple variables in Java will always take a big of one space. This loop depends on the, this is also a space extra which is big of 1. This loop takes a big of n because it depending on the size of the array directly. This loop takes the minimum string length, means the string in the given string array which has a minimum length, then that many number of times only this loop will be run. So minimum of string of length, and this is also same, multiplying this both will get this value. So now we will write the final time and space complexities, which are time is equals to, inside this loop it gets n into minimum string length. So the inner executive statements. So now time is the maximum possible value of the time from the whole code, which is also same, n into minimum of string length from the given array, and space is big of 1. We didn't use any extra dynamic space. So if you check minimum of array I, it means the same one. The minimum length of string which is present in the given array, that many number of times the inner loop is running, but the outer is running actually the n times. So n into minimum of array of I. So the time is space, the time is same as our code, but the huge difference is coming to the space. So we see they gave the minimum string length of space we can use, the dynamic one. But what is our space? It is constant space. So our code is more optimized than the expected which they asked. So this is the best possible solution for this program. Kindly go and practice this program. The problem link is given in the description. Thank you for watching. Subscribe for more videos.